Like John said, super excited to be here. Been an Ubuntu user and been part of that community for quite some time, so it's super exciting to be here on stage to speak a bit about something that I've been spending the last 8 months of my life deep diving into. So if my clicker works, and it does. So who am I? John gave me a quick introduction. I've been in, oh, sorry, my slide does not work properly, so let's see if I can fix that real quick. So I've been doing startups for quite some time. I've been doing tech for even longer. And you may know me from Screenly, which we've been using Ubuntu Core for quite some time. And as John alluded to, we are, I believe, the largest fleet of Ubuntu Core out there. Our specific focus around Ubuntu is around, or signage, I would say, is around secure signage. So that's really what our strategy has been from day zero, is to be like a really secure signage solution. And that's why we started working with Ubuntu and Ubuntu Core to make sure we can deliver on that promise. And for those who were around the summit for the weekend, all the screens that ran around the summit, they were all running on the Screenly platform. So that gives you an idea of what we're doing. These are some of our customers. What you can see on this list is that what ties most of them together is that they are very security conscious. We have NAS as customer, we have Lowe's as a customer, we have Amazon as a customer. All of these people care a lot about security. And that's kind of what led me down to the path of SBOMs. Last year, I started receiving quite a few requests from customers asking us to provide them with SBOMs. I'd heard about SBOMs before. I've seen at conference people talk about them, but I never really paid much attention to it because I thought it was just another one of these security things that people talk about. But as we started to get more and more of these requests, I started to think about, well, actually, why is this happening now? And the reason why last year was the timing when we started getting these requests was largely around the Executive Order 14028. This sounds like gibberish, but what this is a mandate from the White House that says anybody who makes software for the US government, or rather sells software to the US government, must provide an SBOM. If not, they're not eligible to sell to the government. This had a massive cascading impact on the industry at large. So you basically started to see customers like we had asking us for SBOMs because there are scenarios where we could be used in part of government. We sell to the US government. We have a lot of branches of the government as customers. So we started to get these requests, and that's why I started going down this rabbit hole of SBOMs. Now, from there, you started to see like the domino pieces falling. Early this year, NIST Cybersecurity Framework 2.0 was released. It stops just shy of mandating SBOMs, but it does hint at what's called software transparency. And this is a phrasing that you see a lot across a lot of the various legislation that's coming through. They call for software transparency as a proxy for SBOMs. 2-3 weeks ago, I believe it was, EU Cyber Resilience Act came through, and much like the other legislation on the other side of the pond, calls for software transparency. You have similar legislation coming into the UK. And the other thing that we really got excited about was a new project from CISA that's called Secure by Design. And Secure by Design is a project that basically tries to force or tries to volunteer hardware and software vendors to follow security best practices. One of the things, as part of following the best security practices, is to provide SBOMs, because you can't really trust a vendor to know what their software security supply chain looks like if they can't actually prove what goes into that. So we joined the Secure by Design pledge, as they call it, and they call for radical transparency. So that really started creating a ticking clock for us at Screenly to get our ducks in a row for SBOMs. So we have about I want to say 8 months left to make sure we have all our ducks in a row for that. Sorry, my voice is a bit bad from the conference. But if you take all these things together, what happened with the executive order, with NIST, it's just pretty clear where the industry is heading. You can expect that the next SOC 2 revision, the next ISO revision, all of these will mandate SBOMs as part of your compliance requirements. So that's kind of the why now question, like why do we care about SBOMs right now? But maybe let's talk about what is an SBOM, because that's obviously a big, important part of this. SBOM stands for Software Bill of Material, and it comes from the manufacturing term bill of material, where you're using to produce a piece of machinery, where you basically define exactly what goes into a particular component. The best way, I think, is to illustrate what an SBOM is, what it does, is make the analogy of when you go into a grocery store and you pick up a chocolate bar, you look at that recipe, the list of ingredients, and you can see exactly what's in there. You can't do that for software. And I think that's the best analogy, what SBOM is trying to address. So it's essentially a JSON file. It can be also an XML file if you really hate yourself. But it's generally a JSON file that is produced in your CI/CD pipeline that describes exactly what goes into a piece of software. Now, we know what an SBOM is. We know why you have them. But what are they actually used for beyond just a tick box in the legal world? Well, if you look at the SBOM maturity lifecycle, the very first level of maturity is the tick box exercise. Yes, I have an SBOM. Great. But if you look at more sophisticated use of SBOM, they're actually using them for real use cases. So the uses for SBOM tend to fall into two buckets. The first bucket is security compliance. So you can take that SBOM that you generated, you can chuck it into a piece of software, and I'll dive into what those are later, and it will give you all the CVs you're affected by. So that's a really, really handy tool for getting a really detailed analysis of your security posture. So that's one set of use case for SBOMs. The other one is license compliance. So if anybody you guys worked in the enterprise world before, or you're working on this deal of canonical working with enterprises, you know that license compliance is a big thing. If you're a big vendor, your legal team will probably breathe down your neck to make sure that you have no what's called toxic licenses in your code base. So no GPL3 and things like that, because that's the company can get in trouble for. That's a common use for SBOMs as well, using them for license compliance to make sure that you're actually using licenses or your components that are compliant with what you need to be compliant with. All right, so the outline of this talk, I'm going to walk you through the SBOM lifecycle. So I'm going to use a CISA phrase here called authoring, which is just what they call a generation of SBOM. So there are three phases here. There's the authoring/generation part, there's the distribution part, and then finally the analysis part. So that's going to be like the rough outline for this talk, and I'm going to dive into each of these sections going forward here. So let's start with generation. So the generation starts where you take some kind of input and you build an SBOM. And the thing to be worth noting here for generation is that there's something called NTIA minimum elements. NTIA minimum elements is what a lot of these compliance frameworks use as the gold standard for SBOM. So when you submit an SBOM, that's kind of the benchmark they expect you to meet. But it turns out that it's actually rather difficult to meet that standard, which I'll show you in a few moments here. All right, so 8 or so months ago, when I started doing SBOMs, I essentially expected it to look like this. You download one of the many SBOM generation tools, you point it to your log file, and you get an SBOM. But you can also say, oh, well, GitHub has an SBOM generation tool. I just got to pull my SBOM from there. Great, I have a final SBOM, tick box, done. Not really. It's a lot more complicated than that. So as I kind of embrace myself in this world, I thought I missed something obvious. Because surely it can't be this difficult. Everybody speaks about SBOMs, can't be that difficult. But I hadn't overlooked anything. After validating this with a lot of people that have been in the SBOM world for quite some time, it is actually as complicated. So I joined a CISA working group, and I'm co-leading that right now, where we are generating a reference implementation for what an SBOM looks like. So we've devised a structure that has 4 phases. 3 of them are mandatory, more or less, and the 4th one being optional. The first one is the generation part. That's what I showed you before. You pick some tool, you point it to a log file, it spits out an SBOM. That's great. Now you have a good starting point. I'll dive into what the complexities of that are later, but that is generally speaking what that first phase looks like. The next phase is the augmentation phase. In the augmentation phase, you take what you generated in the previous step, but then you need to augment that in order to be compliant with the NTIA minimum elements. And in the augmentation phase, we do things that are not possible to do automatically by the generation tool. We provide things like, who are you as a vendor? What's the license of this piece of component that we're building? You have to point out contact information about who generated this and all those things. So it's basically things that you can't automatically assume based on the input. Depending on what that input is, you also might have to include like the version information as well. And then once you've done all of that, we need to add the next step, which is the enrichment phase. And then in the enrichment phase, you take that SBOM, you look at all the components there are, or the components inside of that SBOM, and then you need to look through all of them and make sure they have all the relevant information. And by relevant information, I mean things like, do we have license data on all the components listed in here? And because that's a requirement for the NTIA minimum elements, we need to include the license data, because otherwise, how can you do a compliance license audit if you don't have the license data to start with? So that's what you do there. And there's a tool from Sneak called Parlay that is using an open data set from ecosystem.ms, which is kind of one of the most common ways to do this. But it's basically scraping GitHub, more or less, and put it on a data set and try to enrich the data. So that's the next step here. And then the 4th phase here is the consolidation, which is optional. You may do that in the transportation/distribution phase. But even in a very basic example, where you say have an SBOM for, where you have an SBOM for just showing a simple microservice, that is probably going to be 5 or so SBOMs. So in the consolidation phase, we're basically mapping multiple SBOMs as references as like a higher level tier. So the alternative to that is you squash all of them together into a singular file, but then you lose a lot of context, which you might want in the analysis phase later. So I'm going to go into the next file formats, how that matters a little bit later as we go into the actual structure. But to say the least, the consolidation phase can be rather complicated. All right. If you've had any kind of reading on SBOMs or an exposure to SBOMs, you've probably already picked up that there are 2 competing formats. The main formats are SPDX, is from the Linux Foundation. It's a project that has been around the longest. And it comes from like a more vantage point of license compliance. And it's been around for a long time, and many of the Linux Foundation projects they get behind SPDX for obvious reasons, so that's why they have quite a lot of exposure there. The alternative format is CycloneDX. CycloneDX is a more opinionated format. In SPDX, there are usually multiple ways to do a single thing, whereas in CycloneDX, there are only usually one or two ways to do a single thing. So it's more opinionated, but by virtue of being more opinionated, it tends to create a clearer structure. So my personal preference is CycloneDX over SPDX. But having said that, I think this is where you have to bring in the mandatory XKCD slide of now there's a third format. And that's the reality. So what you're starting to see more and more is that people are kind of fed up with this, oh, do you want to do CycloneDX or SPDX? And different vendors say, oh, you need to provide it in this format or that format. So you have started to see a rise of like meta formats where they store them in a meta format and then you can export them to one or the other. I hope that we will not have the format debate in 5 years from now and that it's kind of like an export feature rather than an implementation problem. Because right now, the two formats are moving pretty quickly together and they kind of diverge and they have their own tool ecosystems. So it's rather difficult to work with both. So if we can get around that, I think that's going to be a net benefit for the entire system. So my hope is that neither of these will win. Rather, we'll have a meta format. All right, so let's go into a bit more of the tools for generating SBOMs. So if you start looking at this, you'll find, generally speaking, two large buckets of toolings. You have the generic tools that aspires to do everything. I'm only focusing on the open source tools here. There is a large set of proprietary tools out there that claims to solve everything for you as well. But if we're looking at just the open source tools, the biggest generic tools you'll find out there are Sift and Trivy. Sift is for Anchor, and Trivy is for Aqua. They can do SBOM generation from a large number of programming languages. They can do SBOM generation from a Docker image in various capacities. You also have a dependency bot here on the list. GitHub can export SBOMs, but the quality is arguable. There was a research paper a few months ago coming out of an Italian university where they actually analyzed the output of the SBOMs generated from GitHub, and it was not great. I've also left out Docker. If you play with Docker, you probably realized in Docker Desktop you can generate an SBOM, but behind the scenes it's actually using, I think it's Trivy, it could be Sift, but one of those tools, just a wrapper on top of it, really. Now, if you dive into the world of SBOMs, you also will realize that there are a lot of domain-specific tools, because usually the way you generate an SBOM is using a log file from a particular package manager. And that's obviously very language-specific. So both the CycloneDX and the SPDX world, they have their own tools for generating SBOMs from various languages. These tools tend to generate better quality SBOMs. So, for instance, if you have a Python project and you want to build an SBOM, the CycloneDX SBOM Python one is probably generating better quality than a generic tool like Trivy or Snyk. So you have a lot of these tools out there. Both of them have a lot of availability for, not for all languages, but for a large number of languages. So we spoke about dependencies and, well, log files rather, but which is dependencies. One big problem here is garbage in, garbage out. The quality of your SBOM is directly correlated to the quality of your log file. So, just used in Python as an example, it's each generated requirements.txt file that is incomplete. But when you do pip install, it will traverse through and pull in all your dependencies. But your log file itself is incomplete. So if you use that as a basis for your SBOM generation, it will be incomplete. And more modern languages will have better, well, I say more newer languages will usually generate better log files. So if you look at things like Rust or Golang, their log files will be generally better than many other programming languages. But you'll see newer package managers, so going back to the Python example, Poetry, for instance, generates a much better log file than many of the previous generations of package manager for that tool. All right, so we spoke a bit about how the gap can be between the quality of the SBOMs, and in SBOMs, we have the concept of source versus build SBOM. A source SBOM is where you use a log file, and you basically use as a basis to build SBOM. A build SBOM is where you look at, rather than the input, look at the output. So you build whatever you're building, and then you look what dependencies pulled in, and then you generate the SBOM based on that. Generally speaking, that produces better quality. But again, this comes down to what is the quality of the log file to start with. Because often these can be the same. So we said Rust has a good example of a good log file. In Rust, they will most likely be the same. But it depends, again, on the quality of the input. Garbage in, garbage out. One thing that also is important to include in the conversation is a good quality SBOM should also include hashes. And that can be sometimes hard to do at source. Some package manager, a lot of package managers these days, do include source hashes. But that's an important extension here. You want to include hashes in your log file, both for security reasons, but also to generate better SBOMs. So let's talk a bit about like the gaps in this. So we talked about you can build an SBOM from a Docker file. That's great, but behind the scenes, what it usually does is just look at the system packages and dump that and generate an SBOM. Here's a very simple example of how you can bypass something like that or actually miss it by accident. Here's a multi-stage Docker image. We're building Nginx for whatever reason, because we want to have some custom flag. And then in the next phase, we copy in that into our final build. If you do something like this, and you do SNCC, oh, sorry, not SNCC, you do Trivia or one of the other tools that can generate an SBOM from a Docker image, that's missing. You won't find Nginx in there. So that's actually a pretty big lack in the toolings. And it's important to know what you're going in there, and you actually have some manual guardrails for that. Another example is a simple way to bypass something like this is to just remove from the database. Right? It's still there, it's still an attack vector, but it's not visible in the database, and therefore it's not picked up by any of the tooling. Now, the same thing can be said about any of the security auditing tools, because many of them just do the same checks, but nonetheless. And the reason why this is important to bring up is that more sophisticated SBOM users, and I spoke with a bank in the UK recently, they use SBOMs as part of their acceptance and deployment policies for production. So if something is found, they will block a deploy, right? They generate the SBOM, they run into dependency-track. If that comes back as something like CV detected, they will block the deploy as a gating. So you can think of a scenario where somebody on a team just finds that annoying because upgrading the Nginx will break some functionality, so let's just hide it. So it's an issue here with like easy to bypass. All right. This is where it started to get a bit more interesting. So when you actually start to build SBOMs in the real world, I alluded to that before, but even a simple microservice will probably have at least 5 or so SBOMs. So here we have an example, the smart thermostat. When you start to decompose this down, you realize that you have so many levels. And when we started doing Secure by Design and SBOM today for Screenly, I realized that this was actually a big problem. SBOM management was a big problem. So I created Spotify, which does a lot of this mapping, but that's beside the point here. The point here is that when you do really large-scale SBOMs, you will end up with a large number of SBOMs that need to become managed. So on the product level, you have a smart thermostat, but then you have project that aggregates all the components upwards. So even in a very basic example, it's important to note that you're not going to have one SBOM. You have a lot of SBOMs. So SBOM management is actually a big problem. Oops. All right, so there are a lot of people in the security team from here at Canonical and Market Security. We kind of already spoke about how easy it is to bypass some of these checks, but there are good ways to do this. I'm not going to dive into the details of how you can do things like attestation, but there is a lot of conversation in the SBOM world, both how you can sign these, and you can trust them, you can tie them into attestation, and a lot of other good stuff you can do. And in particular, if you're running your CI/CD on GitHub, GitHub has done a lot of things to improve how easy it is to sign these manifests. All right, so we now assume that you built your SBOM. You now generate an NTIA-compliant SBOM. That's great. But the thing is that you're going to be generating a lot of these. And I spent a lot of time over the last 6 or so months speaking to CISOs for various companies. And the way people deal with SBOMs today is very manual. I quote many CISOs where they say basically like, yeah, I receive SBOMs from my vendors, I chuck them into SharePoint, and that's it. So there was a CISA primer that was announced last year where they basically call for people to just automate this flow. Because if you're a company like Google or GitHub, where you might deploy 10,000 times a day, you're going to have 10,000 or so SBOM changes every day. You need to have an automated system for that. So that's kind of why we built SBOMify to be that hub in the center where you can ship SBOMs and invite stakeholders to. And that then integrates with your analysis tool as well. But we don't try to be like a closed garden. We are part of a team out of CycloneDX called Project Koala, or the T project, where we're trying to create an open standard for how SBOMs are created, distributed, but also discovered as an end user. So it's a project under CycloneDX, and it's currently undergoing the ECMA standard to become a proper standard under the ECMA. And I'm very bullish on this, and I'm going to show you a slide in a bit on how that actually works and ties together, because I think it's very powerful if we can make these SBOMs more operational. The last part of the life cycle, so we have the generation, we have the distribution, but then we have the analysis part. And this is where actually the actual value comes from the SBOM, right? And again, I'm going to exclude all the proprietary tools here, and that leaves you with 2 of these cool tools. And one is dependency-track, which is a CycloneDX project, well, related to CycloneDX, and Guac. Those are the main tools. Dependency-track is the one that's been around the longest. It's only supporting CycloneDX SBOMs, but it's heavily used even in like large organizations. It's used by tens of thousands of organizations already for that, and it's largely used as an API and integrate into various workflows. All right, so let's take a step back and kind of like go back to that whole chocolate bar example. So imagine you go into an electronics store, and instead of having, obviously, you can't fit an SBOM on an actual physical box, but what we're working on in Project Koala is to map a particular barcode that you already have on your consumer product goods and map that against an SBOM. So you can pick this product up, scan that barcode, and we map it against this discovery process where you can say, this is the physical product, and you can traverse that down with the SBOM. So that's something that we are working on right now, and APIs are being designed both for the publisher and for the discovery part as a consumer. So those are things that have already been worked on as we speak right now. Now, SBOMs is just a small part of this. So SBOMs is the focus we have right now, but the vision is so much grander. There's an overarching concept called OBOMs, operational bill of materials. That kind of ties together all these different SBOMs for various reasons. So we cover the SBOMs on your left here. We also have something called CBOMs, which is a cryptographic bill of material. The CBOM includes things like what cryptographic algorithms are you using in your application. It tells you like potential weaknesses in those, so you can audit that without actually auditing the source code. We also have something called SBOMs. SBOMs are a BOM describing how an application runs. So this one is running on Google Cloud in this region, would fail over to this region. So it tells you all about how it's actually running. Then we have ML bombs, or AI bombs, as they call sometimes. And that's a bomb that describes what goes into machine learning, or LLMs. Now, that's a very hot topic. A lot of the producers of LLMs are less than open to produce what actually goes into their data sets for probably to cover their own backs. But that's actively being worked on, and some big players are already in that space. You also have HBOMs, which is kind of ironic because now we come full story, because an HBOM is actually a bomb for manufacturing. So we kind of come full story here. And that's still folded in, so it fits into the whole like structure. Like a bomb is not a traditional manufacturing bomb, doesn't fit into the technical. It's not machine readable in the same way as these are designed for. So there's still value here. And then lastly, we have VEX. And VEX is the output from your security audit of your SBOM. And that basically tells you things about, oh, I'm vulnerable to these particular vulnerabilities. And then you can annotate them and say, actually, we're not actually impacted by this because we're not using that function in that library and so on. So there are ways to declare vulnerabilities inside of an SBOM. Or you reference it inside an SBOM, rather. All right, so after merging myself in the SBOM world for like 8 to 10 months now, the state of SBOMs is kind of early days, I want to say. Meeting the NDAA minimum elements is far from trivial. It's possible, but it's far from trivial. There's a big debate in the SBOM community about the threat of unknown unknowns. As I showed you in a few slides before, it's very easy to obfuscate things out of or remove things out of an SBOM. But I think we need to still appreciate that it's still better than nothing. It's a starting point. Those things can be addressed later, but we need to get the ball going. And if you marry this with things like attestation, you can actually have fail-safes and do assertions based on that. So it is possible to actually improve. But we need to get started. No, we shouldn't get the perfect to be the enemy of like good, right? So we need to get this out. And what I really want, and what we really need as a company, as if I'm putting my Screenly hat on, is we need to be able to get SBOMs from Canonical. Like, we have built SBOMs for our backend, for our frontend, for our Docker images. Most of that is already sorted. The thing we can't do yet ourselves is SBOM for core, for instance. That is a big pain point for us. So that's what we want to bring up here and make sure we bring folks on here. SBOMs for desktop and server aren't that important to us right now in this phase, but I know with CRA on the horizon, a lot of companies will need to be compliant for that as well. So there's an urgency to get that done. The next thing is SBOM for Snapcraft. Snapcrafts are more complicated to generate Docker SBOM files for, and for good reasons. I mean, they're kind of a lot of the things that go into a Snapchat file are more similar to manually compiling Nginx in a Docker file. So they're a lot more difficult to do. But it's something that needs to be solved. We need to be, even if that requires some manual work, it's something that needs to be done. So with that, I kind of want to leave over to a Q&A session, and we're going to get Alex out on stage.